Okay, so for number 6, oops. All right, so I'm going to flip over here, get out of number 5. Let's do number 6. Okay, so it says in both of the contexts, average speed and race time, number of gallons used, and fuel efficiency, it can be argued that the domain should have an upper limit. In other words, the domain should not be all positive numbers, but should have a maximum value. Do any of you have a car that takes an infinite amount of gas? When you're pumping gas, do you just keep going and going and decide to stop at some point, or does the gas pump click and say that you're done?
Click.
Yeah, it always clicks because your gas tank is not infinite. It has a limit. Most cars are like 13-ish gallons of gas in their tank. So before we said that our domain was G greater than 0. Okay, because they told us we had to put in some gas, all right? It couldn't be 0. They told us, they had to tell us that in the problem. And then we just said, okay, well, we don't know how big the tank is, so we'll just say it's something greater than 0. Now they're saying, they're pointing out that our tank is finite, that we have to have a limit. So it says, A, provide reasoning to support this argument. So let's see. I kind of already explained it, but I want somebody to explain it in their own words. So Katie, can you give me an explanation for why we cannot have this as our total domain?
So that domain is basically saying that any number greater than 0 could be the answer, like the amount of gallons, and
Yes, exactly.
the car does not allow you to like get an excessive amount of gasoline.
Yeah, so the car's gas tank
Miss Roberts.
will, yes.
I was trying to tell you that I stopped seeing your screen.
Oh, you did?
Yeah, like a while ago.
Like before I started recording or after I started recording?
Probably before. I was trying to talk and I raised my hand.
I'm sorry. Okay, is this working now?
Yes.
Thank you for telling me, Rashani. I'm really sorry about that. So did you guys, so Rashani, will you tell me how far into number 5 were you able to see me writing?
I didn't see nothing.
You didn't see anything? Did anybody else have the same problem? Katie, have you been able to see me? How far were you able to see?
I've been able to see the whole thing.
Okay. Okay, well, I'm really sorry about that, Rashani. I'll obviously put this recording up and I'll put this paper up so that you'll be able to see our notes. Oops, I went backwards instead of forwards. Okay, so in number 6, Katie said the car's gas tank will stop you from putting more gas in. And I'm going to add to this, Katie, because the tank can only hold a finite or fixed amount of gas. Okay, and then part B says what values would make sense in each situation. Let me see which I'm not sure what it means by each situation, but let's just say so it's asking what values would make sense. So I think that our G should still be greater than 0. So we have 0. Our G should still be greater than 0. But then I think that a gas tank on average is about 13 gallons. Okay, so G should be between 0 and 13. Okay, If somebody else has a car that takes more, feel free to shout out a different number. But I think that this would be a reasonable guess for you to
24.
have made. Huh?
24.
24 gallons. So maybe, okay, maybe somewhere between there. Okay.
That's
Great,
what my
so-
dad cars takes.
Really? That's so much. I guess he has a big car. Maybe a truck or something. So, all right. So that was number 5 and 6. So that was all of last night's homework. We have about 15 minutes left. So tonight you guys are doing 7 and 8. So let's talk about 7 and 8 real quick. So for number 7, it says inverse variation function family. So we have a bunch of different inverse variation functions right here. So, and it's asking you to look at the key features for each of those. So what I would say, and if you have, obviously all of you guys should be able to pull up Desmos on your computer. I guess I'll go ahead and do that. That might be better than showing it on my phone. So you can get Desmos on your phone or your computer. Also, if you need a TI-83 calculator, why is it doing this? So if you need a graphing calculator from school, please let me know. The first week of school, Miss Kizzy was outside waiting for anybody that needed one. If you didn't go last week or were not able to, please let me know so that I can ask her when she can be available. So an easy way to do this and to compare would be to type these functions that they give you into Desmos. So to do that, you'll go, you just click Start Graphing when you go to desmos.com. And then you can type in f of x equals 1 over x, exactly like they have it right here. Okay, and it'll show you that function in red. Then we'll go ahead and do the other one. G of x is 5 over x. And h of x equals negative 2 over x. Okay, so we have these 3 different functions, and we can see the 3 functions turn out very differently. Okay, so we can look and compare how they are. So like the red function is a little deeper, a little closer to the axes, whereas when this constant of proportionality increases, it gets farther away. The negative sign flips the quadrants that it's in. So this green one is in the 2nd and 4th quadrant instead of the 1st and 3rd. So you can compare and contrast those and look at those key features. And all you're going to do, you can go back to number 5 that we did together today, because it asked us for the key features of that graph. And you can just kind of emulate what we wrote for number 5 here, but for each of these new functions. So I would go ahead and graph each of those new functions out and then look at the key features. Let's see, then it says identify key features. This is just it asking you to fill out the table. Let's see, what is it referring to when it says K? Regardless of the value of K. K, I'm pretty sure is referring to the constant of proportionality, but it doesn't ever define that. So look at the things that change. So what it's saying here when it says value of K, or regardless of the value of K, it's talking about the constant of proportionality. So it's saying which things are not the same depending on K and which things are the same depending on K. Okay, so hopefully that made sense. What questions do you guys have on part A and B right here? Okay, so no questions. So for so I already explained it once. I'll post the videos. You can go back and listen to the explanation again if you're confused. And just read these really carefully to figure out which one means which. And then it says number 8, how is the shape of the graph for an inverse variation function related to the values of k? So if you look at the Desmos page that we did, the values of k are 1, 5, and -2. So it's asking how does the shape of the graph change depending on what k is. So depending on what the constant of proportionality is. And so it says what happens to the graph as the values of k increase from 1, are between 0, 1, and are negative. So try values in each of these intervals and see what happens. What's the difference in your shape? Okay, so that's a brief explanation of what 7 and 8 are. Let's see. So what questions do you guys have before we end our meeting? Okay, so we are 10 minutes.
Miss,
Amar, what were you gonna say?
can you give me page 5, number 5?
Oh, are you talking about the answer for number 5?
Yeah.
So
The
we
one
went
we
over
just-
that the first part of class. I'm going to post the paper that I wrote all of that information on our page. Okay, we don't have time to go back through all of number 5 right now.
Okay.
Are there any other questions before we move on? Okay, so we have about 9 minutes left. I will be on for the next 9 minutes in case you have any questions. If you don't have questions, you're free to go ahead and start working on 7 and 8 for today's classwork and homework. So I'll see you guys later.